What I would like to spend the next few minutes speaking to you about is a project which is partially funded by ALMA. It is just getting underway. It is a Genome Canada funded project, and we're set to sign our contracts by July 1st. A very exciting project, the first that I'm aware of in the industry that incorporates genomics into swine health, and we're hoping to make substantial progress over the next 3 years. Graham Plastow from University of Alberta is the principal investigator on this project. I'm one of the co-investigators along with Bob Kemp, who represents PigGen and the Canadian swine breeders. There is a need, a tremendous need in the swine industry that we control disease, and in many of the industry strategic priorities that have come out both US and in Canada, two diseases raised to the surface. And the first of those diseases is called PRRS, P-R-R-S, which is porcine respiratory and reproductive syndrome virus, and we'll talk a bit about that in a little bit. And the second is another virus called porcine circovirus, or PCV2, and in Canada, the estimation is that each of those diseases cost well over $100 million each annually. And whether you believe that number or not, it's a very significant number. And when you add on that those could be year-over-year costs, we have very significant issues here in the industry. We have a tremendous opportunity in that we really have made no progress over the last 10, 15, 20 years in selecting animals to be genetically or genomically less resistant to disease. As an example, PRRS is uncontrollable in North America at this point in time. There are 2 vaccines on the market, but because of the virus, and it's an RNA virus that mutates quite rapidly, the vaccines are essentially ineffective in many situations. We've been talking about selecting genomically for disease resistance for a long time. There have been a number of researchers focused in on the major histocompatibility genes and have made some progress, but nothing on a large scale. And this project, we hope to do that using the current platforms. The very promising thing, I think, from our point of view is that any progress we make today will be accumulative tomorrow and the next year. So we hope to then bring genotypes back to the swine industry that then are less resistant for years to come. A bit about the technology and these diseases. The first one is an RNA virus. It causes 2 syndromes in the pork industry or in affected pigs. One is a reproductive syndrome. The virus infects adult sows. It crosses the placenta toward the latter third of gestation. It infects neonatal pigs. It kills neonatal pigs. Sometimes those pigs then are infected at birth, survive, and then move into other production phases and infect other animals horizontally. There is another whole syndrome, and that is these pigs that become infected later in life, and the virus targets the immune system, and specifically in the lung, and it wipes out essentially the first line of defense called the pulmonary alveolar macrophage, and results in a pneumonia. But more impressively, it results in immune suppression, so that the pig then succumbs to other diseases that may be present in the farm. So very devastating, many different strains. Some can kill animals outright, other ones cause abortions, and other strains, ironically, do very little to animals after they infect. On the other hand, this other disease called porcine circovirus is a very, very small virus. It's a very simple genome. It's only about 1.8 kilobases, which in viral terms is very small. It's the smallest mammalian virus that we know at this point in time. And it was a discovery of ours in Western Canada about 15 years ago. And it does a couple of things as well, very similar to PRRS in that it crosses the placenta, and depending on the age of the piglet, it may kill it, or that pig may be born infected with PRRS or with circovirus. We think of circovirus more in terms of its impact on the feeder pig or the pigs after weaning, in that when it was discovered back 15 years ago, it would kill pigs within, well, 3 to 6 weeks of weaning, sometime in the nursery or early grower finisher stage, and it causes wasting or tremendous weight loss. It affects the immune system, again, causing tremendous immune suppression. It can cause diarrhea. And what we found initially, and hopefully you can see this from the picture that you're looking at, is causes jaundice, which is a hallmark of liver failure. And there are very few diseases in the pig world that cause pigs to turn yellow, and this was one of them. And this is one of the reasons why we said we have something that was interesting and unique here, and that led to our discovery back in the mid-1990s. So really, in a nutshell, this project, which is funded by the Genome Centers in Western Canada, is really designed to put diagnostic tools onto the ground within a 3-year period so that the industry will benefit. And we're really excited. It models circovirus and PRRS, but we hope that it will extend to other diseases as well. And what we find very interesting and exciting about this project is that we've got tremendous international collaboration, for one, and the second is that we've got buy-in from the industry. So any tool that we find in the lab, in the basic sciences, we can apply to the industry and have 95% of the genetic companies across the country adopting that technology in the manner to which suits them within a 3 or hopefully a 5-year time period. So we will do a couple of things in that process. First, we have some basic science and animal models. We have some applied models, experiments or studies that we'll use in the field. And then we've got a tremendous database or a whole process where we capture data, do the bioinformatics, and then through that make discovery and innovation and move that back into the field. Another very strong component of this is the GELS program that we will then solicit viewpoints from the public on their thoughts on the use of genomics for food-producing animals, specifically pigs, in order to, I guess, prepare ourselves for the adoption of this technology and what the industry would have to do to make genomics more acceptable in terms of public and eating pork products. The partnership that we have, it's a $12.5 million project in total, many different projects, 4 universities of Western Canada at the top. PigGen is a company that is a collaboration of the research arms of 9 different breeding stock companies in Canada. Most of these companies are also multinational, so that any technology adopted in Canada will obviously be adopted worldwide as well. Because of the biosecurity advantage we have in Western Canada, most of the nucleus operations for these multinational companies are situated in Western Canada, which is a huge asset to our industry. And then we've got many other collaborators, including ALMA and the Canadian Swine Health Board here, that have funded various parts of this project. And as well, we've got our international collaborators, Iowa State University, Kansas State University, USDA, Nebraska, and the Roslin Institute. So the key strengths of this project, number one, we're focusing in on pig health. As I said previously, that is really the strategic priority of many of the agencies, the industry agencies funding pork research across North America now. We've got leadership of the industry via PigGen. We've brought this GELS component in, which is a requirement of Genome Canada and development projects, but I think we have a very strong GELS program in comparison to some of the other projects. We'll enhance 2 projects specifically that are ongoing in North America, funded by the USDA and the National Pork Boards in the US, and those are involving feeder pigs. And in addition to that, we have 2 new animal models that we'll be developing, one in pregnant gilts using PRRS, which is what my project is in Saskatoon, and a second one using commercial operations targeting about 4,000 gilts going into commercial farms across the country, and that project is just getting going as well.